Hello everyone! Welcome to the Icewine Knowledge class. In our last episode, we introduced the VQA, the Wine Quality Alliance of Canada, and the strict standards it is set to ensure the healthy development of ice wine. These rigorous guidelines safeguard the quality of every bottle and give Canadian ice wine strong credibility on the international stage. This episode, we're diving into a sea of knowledge to explore how growers here cultivate and harvest the grapes used to make ice wine. We'll also uncover the scientific principles behind this magical, intensely sweet ice wine grape juice. Class begins now. Part 4. Growing grapes for ice wine. Number 1. The star grapes of ice wine. Ice wine is so exquisite and precious, but can just any grape be used to make it? Today, let's take a closer look at what kinds of grapes qualify as the true stars of the ice wine world, and what special characteristics they must have. The first characteristic of ice wine grapes is their aromatic profile. Ice wine is renowned for its rich, fruity aroma, so the grape variety must naturally possess strong aromatic qualities. These aromas need to remain and even intensify after the freezing and concentration process. As Carl Kaiser once said, the grapes must have aromatic characteristics because without layers of aroma, a sweet wine is nothing more than sugar water. The freezing process of the grape juice concentrates the aroma-active compounds, such as esters and aldehydes. These aromatic traits preserved in the high-sugar environment give ice wine its complexity and distinct character, preventing it from tasting overly sweet or one-dimensional. Among the grape varieties that have strong aromatic qualities and are suitable for ice wine, Vidal features rich and long-lasting tropical fruit aromas, including lychee, mango, and dried apricot. Riesling gives off delicate and elegant aromas of citrus, honey, and minerals. Meanwhile, Cabernet Franc, one of the few red ice wine varieties, offers fresh, fruity notes of strawberry and rhubarb. The second key characteristic of ice wine grapes is high acidity. Ideal ice wine grapes must have naturally high acidity to balance the intense sugar concentration, creating a refreshing taste. Finished ice wine typically contains 190 to 220 grams of residual sugar per liter, while the titratable acidity needs to reach 10 to 13 grams per liter. By comparison, regular wines usually only require 5 to 7 grams of titratable acidity per liter. High acidity ensures that ice wine doesn't taste overly sweet, and it also extends its aging potential. For example, an outstanding Riesling ice wine can age for more than 50 years. Among grapes suitable for ice wine, Riesling has the sharpest acidity with the lowest pH, giving the wine a solid and well-defined structure. Vidal has slightly lower acidity than Riesling, but it is still enough to balance the sweetness. Its malic acid content is relatively high, making up about 84%, which gives a refreshing sensation. Cabernet Franc has lower acidity compared to the other two varieties, but among red grapes, it is still considered relatively high in acidity. The third key characteristic of ice wine grapes is late ripening. Ice wine grapes must be late ripening varieties, allowing them to mature slowly through the autumn and remain on the vine into winter to undergo natural freezing. As mentioned earlier, ice wine harvest takes place after November 15th, usually starting between December and January. Late ripening ensures that grapes experience multiple freeze-thaw cycles before harvest, enhancing the complexity of their flavors. This characteristic also extends the time the grapes remain on the vine, allowing them to wait for sufficiently low temperatures without falling off prematurely. Late ripening grape varieties include Vidal and Riesling. They have a slow and steady maturation cycle, allowing them to remain on the vine through winter without falling off, making them well-suited for a long growing season in cool climates. The fourth key characteristic of ice wine grapes is thick skins and sturdy stems. Because they are late ripening, ice wine grapes need thick skins and strong stems to remain intact during the cold, windy and snowy winter conditions, preventing them from falling off or rotting. The thick skins and exceptionally strong attachment of the grapes to the stem allow them to hang on the vines deep into winter, braving frost, ice, and hungry birds. This remarkable natural toughness greatly reduces losses before harvest, ensuring that only the healthiest, most concentrated berries make it to the press step for ice wine. Among the grape varieties ideal for ice wine production, Vidal stands out with its exceptionally tough skin and strong attachment to the vine, offering excellent resistance to freezing temperatures and physical damage. Cabernet Franc, among red varieties, has notably thick skins, making it particularly well-suited for crafting red ice wine. In comparison, Riesling has relatively thinner skins than the other two. Therefore, in the late growing season, it requires extra care, such as precisely timing the harvest and implementing special anti-frost and bird protection measures to ensure the grapes reach perfect condition for ice wine pressing. Another characteristic of ice wine grapes is their exceptional disease resistance. These varieties must possess strong natural defenses, particularly against noble rot, also called Botrytis cinerea, and mold caused by winter humidity and damp conditions. Grapes infected with noble rot, which is perfect for crafting another legendary sweet wine, are entirely unsuitable for ice wine. Noble rot causes the berries to shrivel and fall prematurely, reduces juice yield dramatically, and fundamentally alters the flavor profile. Ice wine, however, celebrates pure, unmasked varietal character. The presence of botrytis would overshadow and distort that pristine, vibrant fruit expression we seek. Strong disease resistance helps the grapes stay healthy through the damp fall and winter seasons, preventing any unnecessary interference with their natural flavors. Among grape varieties, Vidal has thick skins and strong disease resistance, with a very low rate of noble rot infection. Uniquely, even when about 10% to 15% of the grapes are infected, it can still be used to make ice wine, although this is not ideal. Riesling, on the other hand, has thinner skins and requires more careful vineyard management, but its overall disease resistance is still considered acceptable. The sixth characteristic of ice wine grapes is their cold hardiness. Although cold hardiness is somewhat related to late ripening, which we discussed earlier, the two traits are not exactly the same. Ice wine grapes and their vines must be able to withstand extremely low temperatures from -8 to -14 degrees Celsius, or even lower, without suffering frost damage or falling off the vines too early. Cold winter temperatures are one of the major limiting factors in grape growing. Only cold hardy varieties can survive long enough to reach harvest. Their cold hardiness ensures that the grapes remain viable even as they freeze on the vine, allowing them to yield high-quality juice. The seventh characteristic of ice wine grapes is their moderate sugar levels. Although ice wine is famous for its high residual sugar and its rich sweetness, the grapes used to make ice wine should not have excessively high sugar levels at harvest. The sweetness must come from natural concentration during freezing, rather than from an already high initial sugar content. Because the sugar content of the grapes in the fall does not determine the sugar level of the final ice wine juice. Their sweetness is shaped mainly by the freezing process. However, if the grapes start with excessively high sugar, as in the case of botrytis grapes, the freezing effect becomes weaker. This not only reduces yield, but can also negatively affect the flavor. Botrytis grapes rely on human intervention to induce noble rot and dehydrate the berries, while ice wine grapes are concentrated purely through natural freezing. These are two completely different styles of grapes. Having moderate sugar levels allows the freezing process to work more effectively and helps maintain a balanced interplay of sweetness and acidity. Vidal grapes typically reach about 20 brix at full ripeness, but after freezing, their sugar concentration can rise to 39 to 44 brix. Riesling starts with slightly lower initial sugar levels, yet after freezing and concentration, it achieves an excellent balance of sweetness and acidity. These sugar levels make both varieties exceptionally well-suited for producing high-quality ice wine. In summary, the star grape varieties for ice wine that fully or mostly meet these 7 characteristics are Vidal, Riesling, and Cabernet Franc. These are the most common and popular ice wine grapes you'll find on the market. Now that we understand the key characteristics of grapes suited for ice wine, let's explore how ice wine juice is actually formed. Why does wine made from frozen grapes taste so rich and sweet? Is it a gift of nature or the reward of careful cultivation? And what is the science behind it? Number 2. The scientific theory of ice wine juice formation. The truth behind the miracle. The formation of ice within the grapes is the core process of ice wine production. As the temperature of the grape juice gradually drops, microscopic reactions within the cells take place, contributing to this phenomenon. Mature grapes undergo repeated freezing and thawing during winter, which dehydrates them. This unique process concentrates the sugars, acids, and aromatic compounds in the grapes, enhancing the richness of ice wine's flavor and giving it remarkable complexity. Let's take a closer look at how ice wine juice is formed and the science behind it. First, the lowering of the freezing point. Grape juice is not pure water. It is an aqueous solution containing sugars, fruit acids, and trace solutes. The sugars, mainly glucose and fructose, make up 18% to 24% of the juice. The fruit acids, primarily tartaric and malic acid, account for 0.8% to 1.2%. Trace elements include amino acids and minerals. The presence of these solutes lowers the freezing point of water, so grape juice does not freeze at 0 degrees Celsius, but requires a much lower temperature around -7 to -8 degrees Celsius to start forming ice. It's similar to how seawater behaves. While pure water freezes at 0 degrees Celsius at sea level, seawater does not freeze at this temperature because the dissolved salts lower its freezing point. In winter, we also take advantage of this phenomenon when we spread salt on roads or sidewalks to melt ice. The second principle is selective freezing. When the temperature drops to -8 degrees Celsius or lower, the water in the grape juice begins to crystallize into ice. Sugars, acids, and other solutes, which are more soluble, do not freeze and instead become concentrated in the remaining liquid juice. This selective freezing is what gives ice wine its high sugar content and intense flavors. But why are the incredible aroma and flavor molecules of ice wine not trapped in the ice crystals and instead remain in the highly concentrated juice? When water molecules crystallize into ice at low temperatures, they form an orderly hexagonal lattice through hydrogen bonding known as the IH structure. This lattice is highly regular and tightly packed, and it can only accommodate water molecules. Larger molecules, such as sugars like glucose and fructose, and organic acids like tartaric and malic acid, are too big and structurally complex to fit into the ice crystal lattice. This also explains why sugars and acids are far more soluble in water than in ice. As more ice crystals form, the volume of liquid decreases, and the concentration of solutes gradually rises. This dynamic process further prevents solutes from entering the ice crystals because a more concentrated liquid is harder to freeze, and its freezing point continues to drop. As a result, to continue freezing the grapes, even lower temperatures are required, which leads to a continuous concentration effect. For example, at -9 degrees Celsius, the sugar concentration of the juice can reach 39 bricks. And at -10.5 degrees, it can rise to 44 bricks. Although even lower temperatures can produce higher sugar levels, the yield becomes extremely low, and overly sweet grape juice is almost impossible to ferment. Eventually, when temperatures drop below -14 degrees Celsius, no juice can be extracted at all, because even the sugars and organic acids have crystallized into solids. Carl Kaiser of Enniskillen once tried pressing grapes at -17 degrees Celsius. He could barely extract any juice, and the extreme pressure even damaged 2 of his presses. Simply put, ice is like a picky diner. It only wants pure water. When water molecules freeze, they line up neatly in an orderly structure. Sugars and acids are too large and complex to fit, like trying to squeeze a big block through a small door. They remain in the liquid, and as more water freezes, the remaining liquid shrinks. the sugars and acids become more concentrated and their levels continue to rise. Third, ice crystal formation and cell damage. When the temperature drops below the freezing point of grape juice, water first begins to freeze in the spaces between the cells. Because these areas have lower solute concentrations and a higher freezing point, making them easier to freeze. As the intercellular water freezes, the concentration of water in the remaining liquid decreases, and water inside the cells is drawn out due to osmotic pressure differences, causing further dehydration and increased shrinkage of the cells. We all know that ice is less dense than water. If ice were to form first inside the cells, the frozen grapes wouldn't just shrivel, they would burst. It's like leaving a bottle of water in the freezer overnight. We all know what happens. The ice crystals that form in the spaces between cells do not immediately kill the cells. As temperatures drop further, for example to -10 to -14 degrees Celsius, water inside the cells also begins to freeze, forming much smaller ice crystals. These ice crystals form within the cytoplasm or cell sap, often in needle-like or branched shapes, directly piercing the cell membranes and walls, causing irreversible damage to the cells. The piercing of cells by ice crystals is a key reason ice wine develops its distinctive sensory flavors and characteristics. When frozen grapes are pressed, the internal ice crystals cause the cells to rupture and even pierce the grape skins, whether breaking the cell membranes inside the grapes or puncturing the skins. This process helps release the juice and liberate the flavor compounds, enhancing the wine's complexity. For example, ruptured cells release sugars, acids, and aromatic compounds such as esters and thiols. During ice wine production, winemakers take advantage of this phenomenon. The contribution of ice crystals is especially noticeable when making ice wine from red grape varieties such as Cabernet Franc. Most red grape varieties have clear, colorless juice because the pigments and anthocyanins are found only in the skins. When making red wine, the grape skins are fermented together with the juice at relatively high temperatures, around 25 to 33 degrees Celsius. This allows the extraction of color and the flavor compounds from the skins. However, during ice wine production, this usually does not happen. The grapes are frozen and must be pressed to extract the juice before fermentation. As a result, winemakers rely on the ice crystals to help release color from the grape skins. Fourth, the characteristic of natural freezing. Ice wine requires the grapes to freeze naturally on the vine rather than being frozen artificially. This natural process introduces temperature fluctuations, creating freeze-thaw cycles. Grapes experience day-to-night temperature differences, for example, -4 to 5 degrees Celsius during the day and -10 to 12 degrees at night. This repeated formation and partial melting of ice crystals leads to more uniform cell rupture, releasing a wider variety of flavor compounds and enhancing the complexity of the wine. In the Niagara region, the ideal harvest window is from mid-December to mid-January. By this time, the grapes have undergone at least one freeze-thaw cycle, which helps develop more complex flavors. Artificial freezing, on the other hand, maintains a constant temperature and lacks this layered dynamic, making it impossible to replicate the natural complexity. In our next episode, we'll take you into the vineyards, venturing into the cold winter nights for a sweet adventure. You'll see how the grape growers and winemakers harvest and press the grapes, and how they protect them from frost and birds, all in the pursuit of producing high-quality ice wine. If you enjoyed our program, please like, subscribe, and leave a comment. Thank you for watching, and we'll see you in the next episode.